do I determine whether a function is linear or nonlinear? Now, before I go any further, I'm going to be using the word function a lot. And so if you haven't watched the What is a Function video, you might want to go back and do that one first. Today, I'm going to show you how to figure out what is linear and what is not linear from graphs, tables of values, and equations. So right here, I've given you examples of what's not linear and what is linear. What do you see that they have different from each other? What do the linear functions have in common? Have you figured it out? Well, linear functions have no bends or curves. The graphs of linear functions are completely straight. So that should be an easy one to identify. Here's a riddle though. Why is this not a linear function? Well, it is linear, but it is not a function. It's not a function because it fails the vertical line test. Every single point on that line has the x value of 2, but has different y values. Not a function. Figuring out if a table of values is a linear function or not does take some work. And so this will probably take the longest part of explaining it to you. I'm going to start with, is it not a function? Let's look at this very first one, and they've already done the math for you. When we figure out if something is a function or not a function, we create a ratio between the change in the y value and the change in the x value, the same two numbers. And so that would be a ratio would be 7 over 2. So I'll just put that up here, 7 over 2. Okay. The next one would be the 11 over 2. And then the last one would be 15 over 2. Well, for this to be linear, these three numbers would have to be equal to each other. And obviously, they're not equal to each other at all. That's why that's not linear. Now, in contrast, let's look at the one right beside it. With the first two, you have a change of -6 in the y over 3 in the x, and then the next one, -6 over 3, and the next one, -6 over 3. And obviously, those are all equal to each other. So that is a constant rate of change. That's going to give you a straight line on the graph. Now let's go back over to the non-examples, and let's look at the last two there. As you can see, these are all going up +1. I'm just going to put that right here. And this looks like it would be a pattern. Divided by 2, divided by 2, divided by 2. However, we don't divide when we're finding constant rate of change. We always just add or subtract. So let's look at the subtraction part of it. -8, -4, -2. And so what you have here is you have a -8 over 1, a -4 over 1, and a -2 over 1. And obviously, those aren't the same numbers. And then right below it, this is a -1, this is a +1, and this is a +3. And this is a +1, +1, +1. So again, you've got a -1 over 1, you've got a 1 over 1, and you've got a 3 over 1. Obviously, not the same fractions. All righty, now let's take a look at the last group over here of the examples. This should be pretty easy to look at. These are all just going up by 1s, and these are going up by 2s. Very constant, a constant rate of change. It looks beautiful. This one right here going up by 1s again, and this one is going up by 3s. And so if the ratios all equal each other, then it is a constant rate of change, and it is a linear function. So a linear function has a constant rate of change. This can be found by creating a ratio of the change in the y value over the change in the x value. And to be perfectly honest, in this case, you could do the x value over the y value and find the same thing. However, soon we're going to be finding slope, and that is always the y over the x. So it's good to stay consistent now. Is this table a linear function? If you have time, pause the video and see if you can figure it out. All right, I'm going to start doing some work here, and I'm going to look at the change of y, and I'm going, all right, that's +6, and that's +4, and that's +8, and this is +4. And I'd be thinking, okay, I'm done. This is not linear. It's not constant. It's not that. But I'm going to challenge you to keep going. This is up 3. This is up 2. This is up 4. And this is up 2. And again, you might be thinking, I told you this is not linear. But let me show you something. I'm going to take this first one and this first one and put it together as a ratio, 6 over 3. Then I'm going to take the next two, 4 over 2. Then I'm going to take the next two, 8 over 4. And then I'll take the last two, 4 over 2. What do you notice? If I were to do division on all of those, they would all equal 2. So it is a linear function. The reason it doesn't look like a linear function is because some of the ordered pairs were left out of the table. If I were to expand that table and go from -1 to 10 and not miss anything, you would notice that the y values would be going up by 2 every single time. So don't make opinions just based on your first look. You have to check every ratio. Now we're going to talk about equations. When I look at an equation, can I tell if it's going to be making this straight line, this straight graph? So an equation of a linear function can be written in the form of y equals mx plus b. But what does that mean? First, you got to know that the y and x will be the actual variables in the equation. We're not throwing numbers in for those. The b stands for any positive or negative number, or even 0, that is added to x. The m is the number that is multiplying times x, which could be 0 or even a fraction. So you could have, I'm just going to do the mx part of it. You could have 2 times x, or -3 times x, or you could have 0 times x, which when you see that later on, the x is just going to be gone. Or you could have something like 1/4 times x. You could even have x divided by a number, and that works also. So here are some examples of linear equations. Y equals something times x plus something. Again, the second one here, y equals x is divided by 3, but if you know something about math, divided by 3 is just the same thing as y equals 1/3 x, like that. 1/3 and divided by 3 are the same thing. Or y equals -2/3 x plus 30. These are also linear equations. You might be thinking, what? How are they linear equations? They don't even start with y equals, and you're right. So this is where we have to look at literal equations, where we have to take each equation and solve for y. So that's what I'm going to do, and then I'll come back and you'll see them all solve for y. Here I've taken the first 2 equations and solved for y. And you can see my work there. Do you remember doing literal equations in the equations unit? This is why we had you do it, so that you would learn how to solve for y, to get it into this form. Now let's look at the last 2, because there's not really any solving I need to do. This one is y equals, and the reason there's no x is because the x is 0. And so it would just be y equals 0x plus 8. We don't need the 0x, which is why you just see y equals 8. And the other one is definitely in y equals mx plus b form. My m right here is the -6, and my b is the square root of 11. I didn't say that it had to be a number that was easy. So that is fine. Here's some ways that you can ruin a linear equation. Basically, these are not linear equations. If x has an exponent, for example, x squared or x to the power of 3. If x is the exponent, for example, if I have 3 to the power of x, that's not going to give me a linear equation. If x is in the denominator, for example, if I have 4 on top and then I have x on the bottom, that's not going to give you a linear function. It's actually going to give you a hole in your line. If x is in absolute value signs, and there you go, I have an example there. Or if x is in a radical sign like this. Those are all going to ruin a linear equation. There is no longer a linear equation. Now there's one more that I don't have here that I thought of later. And that's when you have another variable multiplying times x, whether it's times itself or times y. For example, if you have xy equals 8, I can't have the x and y multiplying times each other. Or if I have x times x, which of course would then equal x squared, which then takes us back up to this rule. There is also another kind of weird thing. If the y is missing and there is only an x, it is linear, but it's not a function. And so we couldn't call it a linear function. It would just be linear. This one right here, I believe, is x equals 4. It's just a vertical line. Can you tell which equations are linear and which are not linear based on what I just told you? There are 4 linear equations. Can you find them? Pause the video. Okay, so here we go. The easiest one is probably this one. You're thinking, but the number's in front. That's okay. I can do that. I can take y equals mx plus b and do y equals b plus mx. That's fine. And this can't be it because it has a exponent. This can't be it because it's under a radical. Oh, this is another one that's linear. Do you remember this? I had one like that we just solved for y. And remember how I said x could not be multiplying times a letter, so that can't be one. So can you tell which one? This is going to be a hard one. Well, I'll tell you what, this is linear because if I solve for y, I'll get y equals something times x plus or minus something. And this one also, this looks ugly. I wouldn't want to do this one, but that also would work. But check out this one right here. When I distribute the 4x times the 8, that's 32x. But when I distribute the 4x times another x, that's 4x squared. There's an exponent, and that's not linear. Here is a recap of the 3 things that I just taught you. First of all, graphs, linear functions have no bends or curves. The graphs of linear functions are completely straight. In the middle, a linear function has a constant rate of change. This can be found by creating a ratio of the change in the y value over the change in the x value, but you have to do it for every single pair to make sure the whole table is linear. And then finally, the equation of a linear function can be written in the form of y equals mx plus b. Sometimes you must solve the equation for y to see if it can be written in this form. And then here are some examples. All right, now it's your turn to go and find your linear functions.